So, so we've been talking about exoplanets and how exoplanets are thought about. We last time we talked a little bit about the thinking of prominent philosophers. Are there planets around other stars? Over 2,000 years ago. And of course, we carefully avoided any reference to aliens building the pyramids or Stonehenge, so we avoid that. We then advanced to the discovery of the first debris field around another star, Beta Pictoris, in 1984, and the first discovery of a planet around any star, which was in 1992 of a planet orbiting a neutron star, in fact, a pulsar. So we are ready. We are now primed and ready for the first detection of a planet orbiting another main sequence star like our sun. So main sequence stars, very quickly, stars are born, they live, they die, and they spend most of their life turning the hydrogen in their cores into helium through fusion. And the stars that do that, which is most stars, those are main sequence stars. So there was a detection of a planet around a main sequence star like our sun, and that star was 51 Pegasi. Let's see if I can bring that up here. There we go. And it's in the constellation of Pegasus, which you see here, the Great Square of Andromeda or the Great Square of Pegasus. You can take your pick, and 51 Pegasi is right there. This was identified in 1995. Queluz and Meyer were looking for exoplanets. And if you think about it, imagine you have a bright halogen headlight on a car that's at night, that's maybe a mile away, okay? It's really far away, but it's at night, so you can see, you can see that halogen headlight. And imagine that you have a grape or a pea right next to it. Enormously hard to see that grape or that pea. So we use indirect methods mostly to find these exoplanets. And the method that they chose to use is called the radial detection method. And this takes advantage of a very well-known concept in physics called the Doppler effect. And you all, whether you heard that phrase or not, you all know what this is. Because if you hear a police car or an ambulance coming towards you, their siren has a rather high pitch, and as it passes you, the pitch lowers. Or if there are any race car enthusiasts, you really hear it. As the race car comes towards you, it's a higher pitch, and as it goes away from you, a lower pitch. So the frequency of the sound changes, and that's true for light too. As an object, an emitter of light is moving towards you, you see a higher frequency of light, and as it moves away, you see a lower. So it looks like, it looks like this. In the upper left, we have some representative star system, yellow star in the center, and a somewhat massive planet orbiting it. And so as the star pulls on the planet, so the planet pulls on the star, and actually moves the star a little bit in a circular motion as they orbit their own center of mass. So that star is at times moving toward us and moving away from us. And you can see that depicted over in the upper right here with those sinusoidal waves. The speed of the star relative to the Earth increases and decreases periodically. And then down on the lower right, we have a cartoon of a spectrum with spectral lines. And you see these spectral lines either shifting left or right, depending upon whether the star is moving away from you or towards you. So that is how they detected that 51 Pegasi b. And here is, in fact, that data. This graph here on the y-axis is the velocity of the star moving away from us or toward us. And then in the bottom, it's a phase angle, but basically it's the phase of the sinusoidal curve. You can think of it as time. And so from this, we can get a lot of information about this planet. Also, if we know something about the star, which we do, because we can look at the star's spectrum, and we can tell what kind of star it is, how hot it is, what size it is. And so by combining these two pieces of information, we know that 51 Pegasi b, and that's, by the way, that's the nomenclature. The first planet that you discover orbiting another star is given the letter B, the second planet C, and so on. So 51 Pegasi b, we know is a large planet, a gas giant. We know it orbits about 0.053 AU from its sun. So it's really, really close to its star, its sun. It has a mass of about half of Jupiter's mass. And because it's so close, as we just found out, talking about orbital dynamics, it only takes a little over 4 days for this planet to orbit. So we have found since then many planets orbiting other stars using this radial detection method. I got this graph here from the NASA Exoplanet Archive, and I'm going to give you the reference for that in just a bit. NASA tracks these things. They track the detections, how many we have today, how many, and what methods were used, and what the physics of these planets and planetary systems are like. And you see on the bottom, the method of detecting these planets is color-coded. And at the very top, you see radial velocity or radial detection method. And in red, you can see about roughly how many planets around other stars we've detected from the radial velocity radial detection method. And as we follow this through in coming weeks, we're going to be talking about each of these other methods of detecting extrasolar planets. So I want to leave you with the NASA Exoplanet Archive. This is just a screenshot I took of it today. And so we know, for example, that there are 5,054 confirmed planets around other stars. TESS, the Transiting Extrasolar Survey Satellite, has confirmed 227 of those. And we have some candidates that we have to work through, but this is the definitive, or I'll say this is certainly a definitive source if you're interested in exoplanets, and I will put that link in the chat.
Thank you.
So that's it for today.
I will put that link in the description of this video for afterwards as well.
Thank you, Andy.
Right, thank you very much for that. Very interesting. I've been following that archive for a long time. It's amazing how it's grown and how quickly it's grown. And there's a lot of really interesting information there. A lot of great graphics and fun facts about exoplanets. Yeah, and it's a great resource. So I'd certainly recommend that. Okay.